Hello and welcome to the Comet webinar on how to protect and secure your backup environment. My name is Josh, I'm the GM here at Comet, and today I'm also joined by Mason, who is our CTO here. And today we're going to be really talking through everything in the security scape, from business considerations for yourself through to threats and some practical tips around securing end user settings, policies, data storage, general best practices, and also the general security of the Comet server itself. So moving on to where we sort of are now and what's really been topical. In terms of the security and the threat landscape, it's really, it's been something that has not only been on the rise, but something that can't be considered necessarily just threats from external hacks or crypto locker. As you might have seen earlier this year around the data center fire at OVH, threats to your data and the service that you're providing to your customers can come in many different forms across it. And it's all of these different vectors that takes into account that you need to be looking to secure and having those general considerations around what you can do to mitigate and what you can also do to protect yourself, will make it even harder for people to be able to access or avoid these types of situations. Moving on to the next slide here is the general business considerations that yourself as business owners will have to be taking into account if you're providing a backup service. The first is, and you can look at these in terms of a checklist or a general way of approaching and questioning these things against your own business and processes. The first is around insurance. So much like you've got insurance for your house or for your car, depending if you're offering a HIPAA or a GDP compliant type of backup, it's obviously quite crucial to have a decent cybersecurity policy in place and with coverage. If you haven't reviewed your insurance around that policy to see if it's covering the type of services and the type of backups you're doing today, or the type of service you're offering or requirements that you've got contracts with your customers, it's something that is always worth reviewing your insurance regularly and ensuring that you do have coverage there. The next is emergency escalation procedures. So this is if the worst case scenario happens in terms of a data situation or business situation around data loss, ransomware, crypto, that type of thing, is having a plan in place for what's going to happen, whether it happens in your business hours or if it happens after hours, and what is going to be a response and how you're going to address to those. Do you currently run drills? Do you have a plan? You won't have a plan in place that if something does happen, you've got the steps in place that you're able to respond to them in a very quick manner, but also to the customers and any sort of reputational impressions from the outside. It's doing the best that it can do to obviously maintain that reputational aspect of your business. And in terms of the two plans, there's an internal one and there's an external one. So essentially, what is the comms plan for communicating to the team? So how your team members respond to the crisis, who isn't affected by the team members, how can they assist, and where does your legal and marketing PR help with that around that situation of your internal comms, your internal plans. What are the internal functions of your business doing to align to those and help? Next is the external. So how are you communicating this with stakeholders, and how are you communicating this also with other customers, or if you're in a situation where you might be having resellers where it's even further down the line, what is the plan and what is the process that you're going out there to discuss with them? How do you address effective customers, unaffected customers? Do you have something in place that if this was to be picked up, or you did have a reporter or some media contacting you around comments, do you have even just a basic outline of a response that you'd be able to have or know how to address it? If you're providing a GDPR or a HIPAA type backup service, and unfortunately the worst does happen, there's obviously some compliance situations around that, along with disclosure that you must adhere to being able to report any sort of data breach or data loss situation. And with that type of thing, it's worth you knowing ahead of time what your obligations are so that you're covered if that sort of situation happens. Moving on to the next slide is just a couple of things that you can obviously work through as your business yourself. Mason's going to be jumping through a lot more of the practical aspects, but again, here are just some more big picture general business things that you can take into account to help with any sort of data loss or data threat scenario. The first is, with a backup business, one of the most important things that you do regularly is testing the restores. There's no point backing data up if you're not testing it, ensuring that the information, not only can you get it back, but also you're able to go through it and to test what you're actually backing up is still relevant. For example, your customer might have just suddenly decided to be saving the data in another location and not told you about it. Then if they have a situation where they need to have their files back, they wouldn't be covered because obviously they didn't inform you or they didn't let you know. So not only test and restores for your own peace of mind, but testing it and double checking with the customer that you're actually capturing all of the important information that they require is obviously a key aspect to that. And that goes certainly in there with the regular review cycle of checking with customers. Obviously, ensuring that you use strong passwords and no matter what system that you're using. Where possible, that you implement two-factor authentication. Always staying up to date with your software updates, for whether it's Windows or other software problems, ensuring that you're not behind in updates. Setting up logs so that you're able to, if anything looks suspicious or you need to do a post-mortem sort of analysis, you've got those logs there to understand what's been happening. Ensuring that you update everything away from default credentials, and by that I mean moving away from admin to things, to utilizing strong passwords and different ways to obviously strengthen that. Securing your devices with anti-malware software, if need be. Securing your network. Reviewing your remote access. So if you've got potential staff members or anybody else outside the organization or that does have remote access, for example, is everybody on the same level in terms of password strength? Is everybody that's connecting in via remote access, do they all need the same level of access? Can there be people that don't need as much access, that it shrinks down the surface of access for people if they were to gain access through that user account? And then the insider threat mitigation, obviously understanding what would happen if, for example, you had a disgruntled employee or you're offboarding old staff, that you don't forget to remove or update user credentials as need be, just through general day-to-day of employees coming and going and other staff members. So these are just some basic things that you could be thinking about in general for your business and how to approach it. Have these considerations, test it with yourself if you've got these, as on the previous slide as well. If you've also worked through some planning management in terms of what if the worst happens, what can I do to mitigate and address it? And just having those in place will give you a lot more surety moving forwards. I'm going to hand over to Mason now, and he's going to be talking more of the practical aspects of addressing security, improving it for your own environment, and also how to implement some further security policies that are available in Comet. So Mason, I'm handing over to you now.
Thanks, Josh. So I'd like to take these general tips and talk a little bit more specifically about the Comet product. So Comet Server is a client-server backup system. The Comet backup endpoint agents communicate with your Comet Server installation, whether that's self-hosted or cloud-hosted. And so there's two main levels of access. There's administrator accounts and customer accounts, and both of these can be restricted in lots of ways. So let's start by talking about the Comet Server for self-hosted. You can install the Comet Server on either Windows or Linux. And either operating system is fine and can be made secure, but it is much easier to make Linux secure because of the massively reduced attack surface. There's no print nightmare, the CVE from last month, because you simply don't install the print spooler. And another point is that SSH is easier to secure than RDP. Remote access to a Windows server is generally by RDP. It's advised to put some other kind of security layer in front of that just for the O days, put it behind a VPN or something. But by comparison, Linux SSH is considered much more secure to expose to the public internet, especially when configured to use key pair only authentication. One more point about key pair only authentication. In the past, SSH security, you would advise prevent root logins, change the port. It just doesn't really matter anymore. If you use key pair authentication for SSH, it doesn't matter if you're root or not. And it turns out there aren't that many ports on the internet, and hackers are really fast at scanning them all. So default port is fine with key pair authentication. Comet Server is a web server. and it speaks HTTP, both to the customer's Comet backup and the admin web interface. So it's all HTTP based. And we made this decision for a few different reasons. One is that in today's world, HTTP seems to be the only thing that works anymore because enterprise firewalls aggressively block non-HTTP traffic. So if you're using a firewall on the server side, it's actually very easy to lock down the ports just to the ports that Comet server needs. The web server is built in and it's fully self-contained within Comet server. So there's nothing extra to install. There's no extra files for it, no need for IIS or Nginx or Tomcat. You can layer those in front if you really want, but Comet has everything built in. So it makes it easy as possible to do the secure thing here. You know, a lot of websites will get hacked because someone manages to upload a malicious PHP file or a malicious ASPX file, and it's just not possible with Comet because it's fully self-contained. So it's secure by design there. Comet is very flexible. You may be sending both backup data and metadata or to the Comet server, or maybe the user's backup data is being sent to the cloud storage. Then there's only metadata communication happening here. The backup data is always encrypted, but in terms of the metadata coming to Comet server, we are relying on HTTPS to protect the metadata communication. If your Comet server is on the public internet, you need to set up SSL certificates for it. It's a hugely important thing to do. So we've made it as easy as possible. It is one click to set up SSL certificates. You don't need CertBot or WinAcme or any external program because we have a built-in Let's Encrypt integration inside our built-in web server. And our built-in web server supports the very latest TLS 1.3, requires a minimum 1.2, so you're okay for PCI compliance. We score an A grade on the Qualys SSL Labs test. This web server, we didn't write it from scratch. It's based on Go's standard library implementation, which is considered a very high quality and high performance server. So this is fully integrated, very convenient, very secure. Let's look at what you can do with it. You'll need an admin account to log into your Comet server. We have a lot of security features for admin accounts. The most basic one of all is that you should use a strong password. Comet server does have a built-in feature for IP allow listing, so ensure this admin account can only log in from your office or from your trusted VPN. Josh mentioned two-factor already, or some parts of the industry call it multi-factor authentication. When you bring in a new defense technique like two-factor, it's important to consider the threat that you're facing and how this defense helps against that threat. And the basic threat here is that someone else knows your password, whether that's through leaked credentials from another site, phishing, social engineering, or just plain old brute force guessing. But it's the leaked credentials that have actually been the major threat in recent years. It's called credential stuffing. You have a nice strong password, you use it for your bank and also for your funny memes and cat pictures website. One gets hacked, your password's floating around the internet, and that same password gets used and reused to attack your account on other websites. And Comet stores all your passwords hashed. Specifically, we use Bcrypt for the main product, the high work factor, and Argon for the accounts and payments platform. They're always validated in constant time to avoid timing oracles. You know, in the unlikely event of a compromise, we're expecting this to not be a specific significant risk factor, but you know, it doesn't matter how strong your password is. If you reuse it, you've created unnecessary exposure of that password. So one way to mitigate this is to use different strong passwords for every website, and we would recommend doing that with a password manager, but two-factor also mitigates this attack because the two-factor keys are unique for every website. In fact, two-factor can help mitigate all three of these methods, leaked credentials, coercion, and guessing, because they'll all immediately hit this next wall. And two-factor support is everywhere in Comet. There's lots of places where you log into Comet. There's our accounts page where you pay your bill, that's got two-factor. There's your Comet server appliance itself, and that's got two-factor. And then there's the end customers who are actually running backups using the Comet Backup desktop app, and that's got two-factor as well. They're all generally supported using TOTP, you know, the 6-digit codes with a QR thing, and it does provide meaningful security. For the admin use cases, we also support using a hardware security key. You have to press a physical button on the USB dongle. The more expensive ones will also verify a fingerprint to make sure you're you. These are considered a bit more secure than TOTP because they're not clonable. If someone borrows your phone for 5 minutes, they can export all your TOTP codes. But one of these can't easily be cloned. You do have to carry it on your keychain, but you can get Bluetooth ones that work on both PCs and mobile. Press the button from inside your pocket. That's very convenient. Hardware security sounds like a big enterprise project, but actually these are very affordable. They're about $10 on Amazon. I would recommend buying 2, registering them both with the app or website, and then only carrying one with you so you have a spare at another location as a fallback. As I mentioned, we support this both in the billing accounts section using WebAuthn, so any key compatible with WebAuthn will work. And also for your admin accounts in Comet server, we integrate using U2F directly. Admin accounts also benefit from full LDAP integration, so your Comet server appliance can be connected to your central user account infrastructure. This is server agnostic, so if you're using AD or Red Hat or one of the new cloud LDAP services like Okta or Google Cloud Identity, to centrally manage your staff lifecycles and password complexity requirements, then it's trivial to integrate that into Comet Server. It's just one click to open the settings area, enter your LDAP DN and group match filter, and Comet Server will reach out to that server. We support both Start TLS and LDAP-S for transport security. Comet will authenticate all logins against AD and also ensure that they are in an authorized AD group to log in. One interesting thing about external Auth and Auth providers like LDAP is that if your LDAP platform has mandatory 2FA, then this can also be a way to get a unified two-factor code across multiple apps and services, because Comet, if you're logging into Comet using LDAP, Comet will block waiting for that LDAP to say you've completed your two-factor handshake. Custom CodeSign installers. So as we start to move down the stack, we're from talking about the admin staff accounts down to Comet Backup at the customer level. Comet Server is able to generate custom rebranded versions of the Comet Backup agent software. And if you do this, you may want to codesign the generated installer. There's lots of motivations behind doing this, but if you have endpoint security software that requires codesign binaries, or if you want to move to that kind of strict allow list of authorized software, getting all this set up is, once again, it's a completely built-in process. No external software required. We have built-in support for code signing Windows with your Authenticode certificate, or with an Authenticode EV hardware security key. And for your Mac OS customers, we can also sign and notarize the software for both Gatekeeper and the notary requirements in Catalina and Big Sur. We have extensive documentation about setting this up, so it's something we would recommend doing to get that assurance for the client software installer. On the endpoint device, Comet Backup is split into the GUI app and a background service. The background service runs as a restricted permission account that has the minimum permissions required for backup and not much more. So this is a deliberate design to minimize the blast radius of any attack. And the GUI lets you control and interact with the background service. It can automatically connect for easy control, or it can be locked until you enter the account password. And this is controlled within the service running as a different OS user account, so there is a meaningful security boundary here. And it means that if a malicious user or ransomware takes over the PC, it isn't able to, but that ransomware is running as the user account and can't break in to admin level. If the Comet app is locked, then the ransomware would be unable to take control over the Comet app. Because there's a lot of things that you can do inside the Comet app. By default, Comet Backup lets the customer interact with their backups, manage them, delete old ones. And so you may be interested in disabling some of those potentially destructive actions. And so we have a highly granular policy system inside Comet that allows you to remotely disable almost any feature of the software. And some that I'd like to highlight are always lock the desktop app to require a password for login, which addresses that attack use case. But if a malicious user is going to get in some other way, then policies can also prevent editing and deleting your storage vaults, or just prevent deleting past backup snapshots within the storage. Or you can even just entirely prevent the customer from using the desktop or web interface, and just require backup jobs to run silently in the background on schedule. But that's the kind of choice for you to make depending on how much active management you provide to your customers. If you want to take on the responsibility of configuring absolutely everything for them, Comet is very flexible in allowing you to make that trade-off, even at different points for different customers. As a demonstration of that, the complete opposite would be our optional high privacy mode. This is a pretty advanced topic, but if you're trying to provide a backup service to customers with extremely high security requirements who can't even allow remote management, it's possible to block a lot of your own access and have that be provable to the customer. And once again, this is just another point on that same trade-off between having high end user control and high remote management. And we leave it up to you. It's completely up to the service provider to make that choice. Now we've come down to the very bottom of Comet, the part that does all the hard work of actually backing up the customer's data. There's two parts to this: how Comet accesses that storage location, the security in transit, and what kind of data Comet stores there when it comes to rest. So with Comet, we're very flexible about where that data gets stored. Comet supports data on local drives, but also FTP, SFTP, Azure Blob Storage, Backblaze B2, S3 compatible, Amazon Wasabi, Google Cloud Storage. And we also support a secure custom protocol for sending data to a Comet server, which can then store it on local drives or proxy it forward to any other storage platform. So it's highly flexible. The customer could be backing up to your own data centers, All the data could stay entirely on-premise behind the firewall, or it could go up on cloud storage. And all of these transports use TLS wherever possible, so we have transport layer security. The next consideration is getting secure isolation between customers. Each customer has their own storage configuration, and you can set up private isolated access keys for their storage. That sounds like a lot of work, but we have some built-in features to make this easier. If you're sending backup data to the Comet server, then Comet server storage role can automatically separate and isolate user data. Or if you're bypassing the Comet server and sending data direct to the cloud, then we also have special integration with Wasabi and Backblaze B2 to automatically create new private access keys for Wasabi and Backblaze B2 cloud storage, which is really helpful to isolate your customers from each other. And if you fall outside these cases, you may have to manually enter separate storage accounts for each customer, but that's not so bad. So this is security in transit. Let's talk about the data itself and security at rest. So regardless of where the data is stored, whether it's secure storage or not, Comet always reads the customer's data from disk, splits it up into chunks, and individually compresses and encrypts each chunk client-side. So it is all client-side encrypted before upload. We also encrypt the file names and all metadata as part of our content-defined chunking store. So it is safe to use an untrusted storage provider with Comet because the storage provider will never see plain text data. You know, the only information leakage to the storage platform is things like frequency and total size. The chunk encryption is AES. To be specific, it's AES 256 in CTR mode. Now, CTR mode is normally subject to some tampering attacks. So we encrypt in MAC with Poly 1305, so we have fully AEAD. That is authenticated encryption with associated data, helping us ensure that the AES stream has not been tampered with. And just to be clear, this is all standard, well understood, vetted, highly trusted cryptographic primitives, all working in the generally obvious way. A little bit complicated, but we love AES, especially in any CPU from the last 10 years has hardware acceleration from it, so we get excellent performance here. In fact, we're so happy with the performance that encryption is mandatory in Comet. Mandatory means you are safe by default. There's no way an attacker can disable it. AES needs an encryption key. We always generate a random key with a full 256 bits of entropy from a platform-specific source. When someone tells you about encryption, your next question should always be, where's the key? Where does the key get stored? There's an old saying that an encryption key should never leave the machine it was generated on. With backup software, we have the interesting additional requirement that we're trying to protect against the case where the customer's PC gets, fully wiped, damaged, lost, stolen. A backup is meant to defend against that kind of against that kind of disaster. And because of that requirement, we're not able to keep the keys solely on the customer's PC. And here we have our first interesting piece of crypto, which is a zero-knowledge ratchet, which is kind of one-way rotor that allows us to take this AES key and store it safely on the Comet server in a zero-knowledge way. Another aspect of securing data at rest is defending against attacks on the storage. Accidental or malicious. If you're storing data on local drives, then you have to worry about disks dying, RAID failures, the file system goes read-only bit rot. And if you're storing on cloud storage, then you get to worry about someone else's disks dying. So cloud storage has strong guarantees, but they're never 100% guarantees. When you have a hard drive failure, or if you have a malicious user messing with the storage, there are three main types of things that can happen. One is if a file is unexpectedly changed, maybe bit rot, file system corruption, maybe a deliberate attack. One of the things Comet does to protect against this is that every chunk inside the storage vault is named after its SHA-1 hash. So it's content-defined storage, and this is in addition to our Poly 1305 MAC in the encryption layer. Comet verifies this hash on every storage and load operation, so we can always tell if there has been a data integrity problem, even before we attempt to decrypt the content. And if you do have an operational event, then we have documented manual commands to scan every file in the storage location. But if that's cloud storage, then reading every file for verification is potentially a very big download. So doing little bits as Comet goes is a good middle ground. Another possible problem is if files are deleted from the storage location. Comet is a backup program. We are very good at bringing back the customer's deleted files, but we're talking here about the actual backup data storage. If something goes missing from here, Comet will detect it using referential integrity checks. Comet is a deduplicating backup program. And so the set of chunks inside the storage all refer to each other in lots of different ways. We have a regularly scheduled pass that scans this web and makes sure that all the references are intact and all the pieces refer to each other properly, this means Comet will automatically detect if a file has been deleted from the storage location. And this is a very lightweight process that we tack onto some other work that Comet needs to do anyway. If a file does go missing, we can detect what file it is. You may be able to recover it from a replica server if you have replication, or a snapshot if you have storage snapshots, or otherwise there are documented steps to clean up all the references and repair the vault that way. Comet also has a defense against files reappearing. Maybe an attacker can't break our encryption, but they can put back in a file that should have been deleted, and maybe that can confuse Comet in some way. And so Comet keeps a generational list of obsolete files, which helps defend against this. That's about as deep as we want to go today. I hope we've managed to demonstrate that Comet is a really solid platform for you to build your secure backup service with. I'd just like to leave you with a few key points. Use a strong password and enable two-factor everywhere. Comet Server offers free SSL certificates with Let's Encrypt. We use account isolation and use client-side encryption before hitting the storage. And you should use policies to lock down the client's permissions depending on your own requirements and a trade-off about customer access versus remote management access. If you have any further questions, we're always happy to help. Send us through an email at hello@cometbackup.com or check out our website from the free trial. So from Josh and myself, thanks for joining us today.